Every year, mining and petroleum workers face life-threatening dangers due to gas leaks, fires, and oxygen shortages. A single methane explosion can cause dozens of casualties and destroy entire operations. And there are two big issues. The first is possibility of explosion or fire in mines due to emission of storage gas, and the second is toxic gas poisoning and suffocation due to lack of oxygen. And turning to consequences, the first is human casualties, second is destruction of infrastructure, and the last is environmental damage. Let's talk about statistics. As you can see, this pie chart illustrates the causes of accidents, and one of the main reasons is explosion and fires, caving collapses, and toxic exposure. The second line graph illustrates the number and rate of fatal injuries among workers in the oil and gas extraction industry by year.
Let's take a look of our innovative bracelet, which is designed to improve miner safety. This bracelet is equipped with various sensors that allows you to monitor the environment and quickly respond to dangerous situations. The main component of our device is the gas sensor that has learned to detect the four most common types of gas that cause explosions and fires, like methane, propan, butane, and carbon monoxide. If the concentration of one of these gases becomes too high, the bracelet automatically turns on the lights and sound alarm. In addition, the continuity bracelet transmits data about the miner's location and the state of the environment to operator's device using GPS module and the ESP32 board. If necessary, the miners can use source button to send the audio signal to the operator and require help.
And let's talk about the business model. Firstly, it's about business to business. Cost of one bracelet is 50,000 tenge. Rent of one bracelet is 1,000 tenge per month. Let's talk about the full mine-safe system for miners. It's about connection of a complete system for miners, which includes 20 bracelets for 280,000 tenge. Also, our team made the competitive analysis. Firstly, it's industrial scientific Ventis. The second one is CCC gas detector, and the third one is Dragger XAM. It's the most spread devices in the miner world. The main disadvantages of these devices is the high price, is 6 or 7 times more expensive than our bracelet MineSafe. The second one is no heart rate monitor, which we have in our bracelet. And the last one is no operator worker system. It's the main one because MineSafe has the bracelet and the application. Let's talk about the market overview. Firstly, it's about the Kazakhstan. So, in 2025, we want to serviceable obtainable market like 81K for workers. The second one is about the Kazakhstan in 2026 to 2027 years. The market overview is like 810K workers. And the last one is the TAM. It's CIS and foreign countries in Asia, for example. And the total addressable markets is like 2.7 million workers. And let's talk about the cost of one bracelet. It's like 1,000 tenge. And the cost of maintenance part is $100. And our profit is like 5,000 tenges per one bracelet. And it's our device, MineSafe bracelet. And there are some resources by which we created our application and local web server. Firstly, it's the PySite 6 and Python, by which we can create our local web server by collecting data. And the second one is Arduino IDE, by which we have coded our bracelet. And the last one is Flutter framework, by which we made our application for workers. Then it's about the hardware, the details by which we created our bracelet. Firstly, it's ESP32, gas detector MP9 that detect gas like butane, methane, and others, temperature sensor, GPS module, and the 3D printer to make the case of our bracelet.
So now we want to conduct an experiment to clearly demonstrate how our device is working. Here is our application. This is a login page and I'm logging into my account. Now this is the main menu. Next I turn on our bracelet and its display shows the gas concentration at around 700 to 750, which is normal level. Now let's begin our experiment. This is the reaction of cuprum with HNO3, which release NO2 gas. First we take a copper, then the oxide. We have already placed the copper, and now we'll add our oxide. As you can see, our bracelet is connected to the application and it's transmitting all data. I'll place the bracelet here, and now I'm adding the oxide. As you can see, NO2 gas starts to be released and the gas concentration on the bracelets drops to a critical level of 70 to 150. This is also displayed in the application, which shows a warning message about the dangerous gas level. Additionally, the bracelet siren is activated and the application displays an emergency alert warning the user of the critical gas concentration.